All right, in this drawing lesson, what we're going to do is we're going to draw the aboral surface of a sea star showing the water vascular system. So a couple things already that we need to know as we draw this member of the asteroidea, class asteroidea. One is that because echinoderms have this pentamerous radial symmetry, they don't have dorsum and venter like we see in other bilaterians. So what we do have is we have an oral surface, which is where the mouth is. It's just usually underneath the sea star, facing the ocean floor. And then we have the aboral surface, which we normally think of as the top of the sea star. Okay, so that's one thing. Another thing is that hardcore marine biologists, they don't call them starfish, they call them sea stars because they're not fish at all. They're echinoderms. They live in the water, so that makes them kind of fish-like, but they're really not that closely related to fish, just like jellyfish. Marine biologists typically call them jellies rather than jellyfish. And the third thing that we learned just from having written this title up here is that they have a water vascular system, which is a closed vascular system in which they use to more for locomotion rather than just like moving around their bodily fluids and things like, try to keep oxygen and whatnot. So what we're going to draw here is kind of like the suggestion of a star, a pentagram. And if you want to know if you've done it right, does it have 5 lobes? Good. And one of the rules of thumb for drawing a good pentagram is see if, these lines all kind of match up. That was not great. That's pretty good. That's pretty good. That's pretty good. So kind of like here on this one, just without those, got to pick up your pen there a little bit. All right. So as we draw the water vascular system, water is going to enter through a structure called the madreporite, also known as the sieve plate. I'll probably just call it the madreporite. And that is going to bring water in to the first canal, which is the stone canal. Stone canal. And the stone canal is going to lead kind of around the central disc, and I'll just kind of draw as a center here, as a circle here, super circle there. And that is going to lead into what is known as the ring canal. And the ring canal is going to pipe that water out into the radial canals. So there's this kind of central ring-shaped canal, which we can label that as the ring canal. And that leads out to radial canals. So each of the arms has its own radial canal inside of there. And then essentially what we're going to do is we're going to choose one of these to draw our detail on. So what we're going to do is we're going to kind of draw a series of balloon shapes, sort of like loop at the top, coming down to form a line. And don't worry if it doesn't look very accurate. We're going to draw a detail of this in a moment. So on either side of that radial canal is going to be a series of these balloon-looking things. All right, and these balloon-looking things, well, I'll get to what they are in just a second here. We're going to zoom out over here, and what we're going to find is that, so we're going to draw kind of a fat end of that. And we find that those balloon-shaped things are really going to kind of look like long drumsticks. So fat end at the top, give it a little bit of a something there at the bottom, like a little swelling. And let's just draw 3. And you can tell I'm awesome at drawing because those 3 things look exactly the same. Almost exactly the same. But what these are, this is how the sea star is able to move, is you've got these tube feet down here. That's what these things are. These 3 things down here, these are tube feet, just one tube foot, multiple tube feet, just like our own personal feet. And then up here at this end, these things that kind of look like eyedroppers, these are called ampullae. So just one ampulla, multiple ampullae. And the way it works is these ampullae store water, and when the sea star wants to go somewhere, it can squeeze water out of the ampulla into the tube foot, which makes it exert out of the ambulacral groove. The ambulacral groove is kind of underneath the sea stars. It's on the oral face of the sea star. And essentially it's where all the tube feet are kind of stored until they need to be used for doing some walking or something. And this is how the sea star kind of can walk along the ocean floor, is by sticking out these tube feet out of the ambulacral groove and using them almost like the sea star is like stage diving on its own tube feet. So all these tube feet are kind of like walking along while the sea star is just kind of like riding on top of them. So that is how what I expect you to know about the water vascular system of a sea star.